Okay, folks, welcome back. Unit 3, Factoring and Applications. Lesson 1 is a review of factoring. So this review of factoring is almost all of the unit that you would have done in grade 10 combined basically into one lesson. So this is going to seem pretty quick, but hopefully you ended up with a fairly decent grasp of factoring last year because it is a key component in pre-calculus 11. So if you can't factor yet, you need to really make sure that you work on this unit because this is going to carry over to 2 or 3 other units after this one. So you're definitely going to want to have a good handle on factoring. So I'm going to jump around in this lesson a little bit because I like the second page where it gives you the big description of the steps to follow. I'm going to talk about this for a second here first. Okay. Factoring, if it involves writing the sum or difference of monomials or binomials as a product of polynomials. Okay. So basically what that's saying is that, well, if I can take this binomial x plus 2, x plus 3, and expand that using distributive property, or FOIL in this case, first, outside, inside, last, to get x squared plus 2x plus 3x plus 6, which simplifies to x squared plus 5x plus 6. If I can expand this to get to this, then I should be able to factor this to get back to this. Okay, so that's how factoring and expanding using distributive property are related. So hopefully that is something that you did remember. Okay. First step in any factoring question, and I don't know how many times I'm going to end up saying it, and I know somebody is going to come up and ask why they can't factor a question. My answer will simply be you have to do a greatest common factor first. Okay. Factor by taking out or removing a common factor. You have to do this step first. Otherwise, some questions may not look factorable. Okay. Then after that, you've got 2 or 3 other options. If there's only 2 terms, then maybe it will factor by difference of squares. Or if there's 3 terms, you might be able to factor it using inspection. Or if you remember from last year, we can also factor using decomposition. Factoring by decomposition. Any trinomial or even a binomial that is factorable can be factored using decomposition. Okay, it's the be-all, end-all. It was something we touched on last year, but wasn't necessarily a testable option. So it should be kind of vague in the back of your mind, but maybe not necessarily a tool that you would use right away. Okay, so let's bypass these examples for a quick second and go on to the second page of the lesson. Guidelines for factoring a polynomial expression. Okay. 1, look for a common factor. See, I'm not the only one that says this. This is the first step. Look for a common factor. If there's a common factor, you have to take it out. If it's a binomial after that, then you can look to see if it factors by difference of squares, which we'll refresh in a minute. Okay. If there's a trinomial, you can factor by inspection, or you may have to factor by decomposition. So the difference is this value for A. Okay. If there's a 1, like technically there's a 1 here, it's just never written, then we should be able to factor by inspection. You can still use decomposition, but a quick shortcut is to factor by inspection. When there's another number other than a 1, we have to use a process called factor by decomposition. Okay, and this is the extension piece that was last year. Okay. If your polynomial has 4 terms at this point, then you could look to see if terms will combine or if you can factor by grouping. Okay, and we'll talk about factor by grouping when we review factor by decomposition. And then at the end, you always have to check to make sure that whatever's left over doesn't factor further, because now we're going to get to the point where some of our questions will do a first step, will factor, but then those factors might factor again. Okay, so you have to double check at the end. Basically, this is your flowchart or tree. First, you're going to look for a greatest common factor. If there's a greatest common factor, you're going to take it out. If there's a binomial, maybe it's difference of squares. If it's a 4-term polynomial, maybe you can factor by grouping. More likely, it's going to be a trinomial in this form. If A is 1, you could try inspection. If A is something other than 1, or even if you want to use it with 1, you can always factor by decomposition. And then again, make sure you check at the end to make sure that everything is properly factored. Okay. So let's get back down to the examples and we'll work through these. Example number 1, factor each polynomial by removing the greatest common factor. So a nice little hint, there's a greatest common factor. So you have to think about the coefficients and the variables separately. What's the biggest number that you can divide into both 15 and 5? That answer is 5. Okay, so that's your greatest common factor for the coefficient. Now we also need a greatest common factor for the variables. And to determine that, you look at each individual variable separately. Okay? X cubed and x squared. Whatever the lowest exponent is going to be your greatest common factor for the variable. So in this case, it's going to be x squared. Okay? X squared. Now, in your mind, what you're kind of doing is, you know what, I'm going to move this a little bit lower. Okay, so once you've determined what your greatest common factor is, now in your mind, you're taking each of these terms and you're going to divide by that greatest common factor. Divide by that greatest common factor. When you do that, well, what's left over? 15 divided by 5 is 3. X cubed divided by x squared. X cubed divided by x squared is just x. Okay. Sorry, I changed colors there, I realized that. And then of course, remember when you're dividing, it doesn't completely just disappear. 5x squared divided by 5x squared, anything divided by itself is 1. So you have to have that 1 there. Right? So there's that one factored. Okay, so let's do example B, or question B. Sometimes with some of these questions that we're working through, as I'm doing these lessons, you don't have to exactly follow along with my voice and whatever. If you want to take a shot at a question, so pause the video, take a stab at the question, and then watch the video to see if you got it right or wrong. That's totally fine too, right? So whichever is going to work best for you. So here we're going to look at this one. We've got 8p cubed minus 4p squared minus 4. There isn't a p in this last term. Okay, there's no p here, so my greatest common factor is not going to contain a variable. But each of these numbers you can see are going to divide by 4. 8 is going to divide by 4, 4 divides by 4, and that 4 divides by 4. So 4 is my greatest common factor. Now in my head, I'm thinking, well, I got to divide that by 4, I got to divide this by 4, I've got to divide this by 4. 8 by 4 is 2, p cubed stays the same. Minus 4 by 4 is 1, p squared. And of course, I don't need that 1 in there. So I don't even need to write that in there. Of course, I erase everything. P squared. Oh, sorry about that. I got interrupted. And then negative 4 divided by 4 is also minus 1. Okay, so remember, you're dividing, you're not just subtraction. That 4, this here can't just disappear into nothing. That's a common source of error, is students will just not write anything there. They'll end their answer. They'll end their answer right here, right? But that would be incorrect because this is a division by 4. So if that's divided by 4, there's going to be a 1 left over, right? So minus 1. Okay, so don't make that mistake. Don't fall into that pitfall. Now, each of these questions, A and B, they are not factorable any further. Okay, I'm telling you that. I just know that. Obviously, 3x minus 1. So that's not going to factor. Anything's going to factor out of here. And nothing's going to factor out of this p cubed. Well, something might, but you guys don't need to know how to factor. You don't need to know how to factor polynomials that are degree 3 or bigger. Okay. You used to in grade 11, in grade 10, actually, you used to have to do it, but no longer. Okay. Example 2, factor if possible using the difference of squares method. Okay, so you have to remember the difference of squares method. Okay, there's a couple of questions you ask yourself to begin with. I'm going to pause my video here and write it out because I want to make it nice and neat. There, so that's probably a little bit neater than it normally would be. So these are 3 questions you ask yourself if you're trying to determine whether a binomial, remember, it can only be a binomial if it's going to be difference of squares. Okay, so the questions you ask yourself: is the first term a perfect square? For example, the square root of, for example, not square root, 25 is a perfect square because the square root of 25 is equal to 5, right? So you can do that with variables too. X squared, is x squared a perfect square? Well, yes, it is, because the square root of x squared is x. If it's an even exponent, then it is going to be a perfect square. Square root of x squared is x to the power of 1. Square root of x to the 4th is going to be x squared. Square root of x to the 6th is going to be x cubed, right? So those are perfect squares. So you ask yourself, well, is the first term a perfect square? Sure. If it is, great. Check. Is the second term a perfect square? Maybe it is. Check. Are those 2 terms separated by a minus sign? Minus sign indicating now it's a subtraction, which is a difference. That's why it's called difference of squares. First term's a square, second term's a square, 2 squares is plural, squares, difference, subtraction. So that's why it's difference of squares. So these 3 characteristics have to exist in order for the binomial to be factorable using difference of squares method. Difference of squares method is a shortcut method. Okay? So let's look at A. X squared minus 81. Is x squared a perfect square? Yes, it is. Is 81 a perfect square? Yes, it is. Are the 2 terms separated by a minus sign? Yes, they are. Now, this is what you do. You think, okay, well, what is the square root of x squared? Well, that's x. What is the square root of 81? That's 9. Now I know what my first term and my second term are going to be in both of my binomial brackets. So I just go straight to my binomial brackets. 1, 2. This goes in the beginning of both. X, x. This goes at the end of both. 9, 9. One's plus, one's minus. Factored. That is difference of squares method. Like I said, it's a shortcut method. If you want to see how you can do that using decomposition, ask me sometime in class. Okay? But this is a shortcut method for factoring using difference of squares. You have to meet all those 3 criteria before you can even take that next step. Okay? Example B. Is 25a squared a perfect square? Yes, it is. Well, what is that square root? It's going to be 5a. So I can go straight to my brackets. Well, assuming this is going to work, okay? So that square rooted is going to be 5a. Is 49 a perfect square? Yes, it is. That's 7. Are they separated by a minus sign? Yes, they are. So now I'm going to go 5a, 5a, 7, 7, one's plus, one's minus. Done. Question C. Is 9x a perfect square? Square root of 9x would be 3x, so yes, it is. Is 4 a perfect square? Yes, it is. 2. Are they separated by a minus? No, they're not. This is does not factor. DNF. Does not factor. That's it. Okay, so now hopefully you have a good handle on the difference of squares method, but you again always have to remember what's the first rule in any factoring question. Factor out a greatest common factor. Now those first 3 didn't have one, but if we look at question D, 16t squared and 64, there is a greatest common factor between 16 and 64, and that's 16. So I have to factor out my 16 first. 16 t squared minus 4. Now I can see, well, this is a binomial. I can check to see if it matches my difference of squares. Is t squared a perfect square? Yes, it is. Square root of t squared is t. Is 4 a perfect square? Yes, it is. Square root of 4 is 2. Are they separated by a minus sign? Yes, they are. So this is difference of squares. So I'm going to write down my 16 because I can't forget my factor if I've taken it out. I'm going to write my two binomial brackets. T is going to go at the beginning of both. 4 is going to go at the end of both. 1's plus, 1's minus. Done. Okay. Example 3. Where possible, factor the following trinomials by inspection. So this is what's going on in the back of your mind when you're factoring by inspection. Okay? So you're looking for, so first of all, this value here is a 1. And it's got to be a positive one too, because factoring by inspection gets messy if it's minus. So be careful. So that's a 1. So that means I can factor this by inspection if it's factorable. So I look for two numbers that multiply together to give 30, this number. Those same two numbers that multiply to 30 have to add together to give me 11. Okay. And then there's some tricks with the positives and negatives that you'll have to figure out and remember and work through. But so two numbers that multiply to 30, add to 11. My choices are 1 and 30, 2 and 15, 3 and 10, 4, 5, 5 and 6. Well, I can't make 1 and 30 add to 11, so it can't be 1 and 30. I can't make 2 and 15 add to 11 either. I can't make 3 and 10 add to 11. But 5 and 6 adds to 11. So my numbers are going to be 5 and 6. 5 times 6 is 30. 5 plus 6 is 11. Factoring by inspection, again, is a shortcut method. Shortcut method. Shortcut methods tend to cause some confusion for some students, so be careful. This is a shortcut method. So if I know that my numbers are 5 and 6, I jump straight to my binomial brackets, and I'm going to use a 5 and I'm going to use a 6, and they're both positive because they're both positive over here. Okay, so positive 5, positive 6. Then what goes here, what's the square root of a squared? A. Okay, done. Question B. B squared minus B minus 30. So again, I'm going to check to see if there's any common factor. There's no greatest common factor. So then I'm going to say, well, I need two numbers that multiply together to give negative 30. Those same two numbers are going to add together to give negative 1. I can go through my choices again. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. But I can see that the only way that I can get this to be negative 1 here is if the 6 is negative. Right? If the 6 is negative, negative 6 plus 5, negative 6 plus 5 is equal to negative 1. I'm going to write this the other way because it's just 5 and negative 6. And 5 times negative 6 is negative 30. So here's a little hint. If this is negative, then only one number is negative, 5 or 6. If it's positive, then they can either both be positive or they can both be negative, because a negative times a negative is a positive. And if whatever value you have here, whether it's positive or negative, is going to tell you which one of these is positive or negative. Okay? Whichever one the bigger one is has to match with that sign. So because 6 is bigger and this is a negative one, I know it's negative 6. Okay? So that's just going to get some, that's going to take some practice time for you to figure out what those combinations would be. Okay, so let me erase that. So now I know my numbers are 5 and negative 6. So I would go over here and say, well, what's the square root of b squared? That's b. B is going to go at the beginning of both of my brackets, b. And then my numbers are 5 and 6. Positive 5 minus 6, go plus 5 minus 6. Done, that's it. Again, it's a shortcut method. Okay. Question C, x squared minus 4x plus 48. X squared minus 4x plus 48. So I'm going to say, well, there's no greatest common factor. There's no x's in all the terms, and there's no number with the x squared, so I can't take out a greatest common factor. I'm going to look for two numbers that multiply together to give 48. Those same two numbers are going to add together. Whoops. Those same two numbers are going to add together to give -4. So again, I've got to figure out what my choices are. Well, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5, 6 times 8. So I need to add to get to -4. Multiply together to give that, add together to give -4. Well, I can't make 1 and 48 add to -4. I can't make 24 and 2. I can't make 13 and 6, or 6 and 16 and 3. 12 and 4 is not going to work, and 6 and 8 is going to be too small. So there's no possible option. Does not factor. Okay. If you're working through some factoring questions, let's say there's 20 questions, and you find like 7 of them don't factor, something's wrong. You got to back up. That's far too many in any kind of assignment like that. Very few questions will be not factorable. Okay. Question D. Question D, 3x cubed minus 21x squared plus 36x. First step, greatest common factor. Is there one? Sure there is. This is going to divide by 3x. This is going to divide by 3x. And this is going to divide by 3x. So 3x is my greatest common factor. What do I get after I divide each of these by 3x? I get x squared minus 7x plus 12. Now, again, I've done some factoring, but I don't know if I'm finished. That's why it's said in those notes. It said in that note right at the very bottom, right? Note, always check to see if there's further factoring. So in this question, there's further factoring. I look for two numbers that are going to multiply together to give 12, add together to give -7. My options are 1 and 12, 2 and 6, 3 and 4. Well, I can't get 1 and 12 to add to -7. Neither can I get 2 and 6 in any way to get -7. But I can get 3 and 4 to add to -7 if they were both negative. -3 plus -4 is -7. Does it work for the multiplication? -3 times -4 is +12. Yes, it does. So now I go 3x, because that's my common factor. I can't forget it. I go to my binomial brackets. I think, well, what's the square root of x squared? Square root of x squared is x. That goes at the beginning of both of my brackets. And then I go -3, -4, -3, -4. And that's factored. Last example. So over the page, we've talked about this page already, so we're just going to keep going. We're going to go to the top of page 95. Top of page 95. And we're going to factor these questions. Now, there's a couple of ways you can do these questions. I'll do one way, and I'll do the other one a different way, just so that you can see the difference. And it's not like one way is more beneficial than the other. You kind of have to know both for a future unit when we start looking at rational expressions. Okay? So it says factor the following: 36 minus 9x squared. So first of all, I look for a greatest common factor. Is there one? 36, 9x squared, there's no variable, but 36 divides by 9, and so does 9. So my greatest common factor is going to be 9. If I divide this by 9 and this by 9, I'm going to get, actually, let's move this down a little bit. I'm going to get 4 minus x squared. Now, this is a binomial, so I checked my whole process of my steps for seeing if it factors by a difference of squares. Is 4 a perfect square? Yes, it is. 2. Is x squared a perfect square? Yes, it is. X. Are they separated by a minus? Yes, it is. So this is a difference of squares scenario. So now I'm going to carry my common factor down. I'm going to write my binomial brackets. I'm going to put a 2 at the beginning of both, and I'm going to put an x at the end of both, and I'm going to make 1 plus and 1 minus, and that is factored. Okay. But it's backwards to what we normally see, right? Normally, we would see this question as 9x squared and 36. Usually we have that variable at the front. So there's a way that we can make that look that way and still come up with the correct answer. It may look different than an answer key or something else, but it is perfectly acceptable. And I'll show you that process in question B. Okay. So 28 plus 3x minus x squared, there is no greatest common factor. Okay, there is no greatest common factor, but this is negative way down over here, and it's in the opposite end of the question that we normally do, right? So I'm going to rearrange this first. I'm going to say, well, I don't like looking at that because it's backwards. So I'm going to say negative x squared plus 3x plus 28. Okay. Now, unfortunately, we can't factor by inspection if this is a negative out in front here. So we have to do something about that. So basically what we're going to do is we're going to do a greatest common factor of -1. So if I divide all of these terms by -1, this is what I'm going to get. I'm going to get positive x squared minus 3x minus 28. Don't forget, I took out a -1, so this needs to be here. Now I can factor by inspection because that x squared term is positive. Look for two numbers that multiply together to give -28, add together to give -3. So this here tells me that one of my numbers has to be negative because it's negative. This tells me that the bigger of the two numbers is negative and the smaller one is positive. So now we think, well, what numbers multiply to give 28? 1 and 28. I can't make that equal 3. 2 and 14. I can't make that equal 3. 3, 4, and 7. Oh, I can make that equal to 3 if the 7 is negative. So it's not this, it's not this. So it's -7, +4. 4 minus 7. 4 times -7 is -28. 4 plus -7 is -3. So I carry my greatest common factor down. This is a common mistake that factor gets forgotten. I write my two binomial brackets. I think, well, what is the square root of x squared? Square root of x squared is x. So x goes at the beginning of both. These numbers go at the end of both. +4 minus 7. Factored. Okay. So this, if we'd have followed the same process over here and just factored it without rearranging, then your answer might look a little bit different in the back of the book. But this is a better process because it's these terms that are more common than these ones, right? When the x or the variable is at the beginning of the bracket is more common than when the x or the variable is at the end of the bracket. And you're going to need to do this process in a later unit when we get into rational expressions because we need to cancel top to bottom, numerator to denominator, and they need to be in the same orientation or written the same way. So you're going to have to know this process eventually anyway. Okay, so for me, I always rewrite my polynomials in the order I want them to be in. So I would have rewritten this straight away too. I would actually have rewritten this one also. Even if I did rewrite this one, this is what it would look like. So I'm now going to rearrange it to -9x squared plus 36. This time my greatest common factor is going to be -9. That's going to give me x squared minus 36. Now I still have difference of squares. That's a perfect square. That's a perfect square separated by a minus. So this is going to be -9 bracket, 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 x, 6, 6, 1's plus, 1's minus. And you can see that this, 6. No, that shouldn't be a 6. That should be a 4, shouldn't it? 36. I forgot to divide by 9. Oops. 4. So that means this is going to be a 2. This should be 2 and 2. There. Now you can see that this answer is slightly different than this one because of the way these are oriented, right? But both answers are completely correct. And again, just as a last time, you're going to need to know how to do this process, rearranging it, because when we get to a later unit, it's going to become very important. That's it for the end of lesson 1. We will see you next time.